What I'm trying to say, we're going to talk about something known as a density curve, okay? And to do a density curve, we're going to look at several different, we're going to do actually 2 data collections today. We're going to talk about, can I find the mean and the median in a density curve, and then draw something called a normal curve. Now, this one should be pretty familiar to you from Algebra 2. You might have called it a bell curve, but you did normal curves in Algebra 2, okay? So we're going to revisit that for just a little bit. Okay. All right, so switch over to your lab sheet for me, and we're going to actually do some data collection. This is where you're going to need the dice. So there should be 3 on each table, or enough for everybody at your table. Some of you have one that just have 5 numbers on it, and then there's a car. The car represents the number 6. Okay, so I've got these from lots of different things. So what I need you to do, take your dice. I only want you to roll it 3 times and write down the number you get each time. Okay, so roll 1. Tell me what you get each time. Okay, so just write down the 3 numbers that you get. So that's what I got. All right? That's what I got. A 4, a 1, and a 3. All right. Now, any idea what you think it would? What do you think's going to happen over time? So, like, if I keep doing it, all right, what's going to happen to my numbers? What do you think might happen to what I roll? There's no right or wrong answer here, by the way. The more I roll it, we'll get different numbers, right? Some will start to repeat, okay? If I took everybody's data and I put it together, what would happen? A lot of different numbers, right? But if we did this over and over and over and over again, okay? Instead of getting different numbers, right, for each one, so these are my 1s, maybe these are my 2s, my 3s, over time, as I do this over and over and over again, we're going to find that they're going to all level out up here at 6, okay? We're going to end up getting an equal amount for each number. So 1s, 2s, 3s, 4s, 5, and 6. So when I have a large amount of data, okay, I have only 6 things I can get. If I continue to roll over and over and over again, we're going to eventually end up with an equal amount of each number, okay? That's why, did anybody win that billion, how many billion it is for the Powerball? Did anybody win it? I thought they drew last night. I might have been wrong about that. My husband and I talked about it, and I was like, should we get one? He's like, nah, we probably won't win. I was like, okay. All right. In Tennessee, you could take it in payments, you know, or you could take one lump sum. If you took it in payments, it would be $30 million a year for the rest of your life. I think I could make do. Just saying. You know, I might find a way to make it work with $30 million a year. Okay. Okay. Do what? They're drawing tonight?
Yeah.
What's the total?
1.3 billion.
God bless. That's a lot of money. Okay. All right. Sometimes I'll pay Mr. Mooney because he's really lucky to go buy my ticket. If he does a scratch off, he wins something every time. Me, never. I never win. Okay. So this is what we call a uniform distribution or a uniform density curve. Okay. If it ends up looking the same, I get the same amount. And one of the cool things about a uniform density curve is we're going to talk about the area inside, okay? We talk about the area inside of that rectangle, okay? Well, since I had 6 options that I could get on the bottom, the length is 6, okay? What would I have to multiply 6 by to get the answer 1? Oh, crazy math right here. 6 times what would give me 1? Anybody know? 1/6, okay? And the reason that we want it to equal 1 is because this is 100% of the data, okay? And so the reason it's 1/6 is because it's always the reciprocal of whatever my length is, okay? So whatever the number of options I have at the bottom, if it's 6, my height's 1/6. What if I had 10 options on the bottom? What would my height be? 1/10, okay? That's a uniform density curve. So the bottom, if the bottom is 6, then the top is 1/6. It's the reciprocal, okay? Remember, reciprocal just means we flip something over, okay? So they would match, all right? We're not going to do that second one because throwing pennies can get dangerous, okay? So we're not going to do that second one, but we'll talk about what happens with it in just a second, okay? But what I want us to do now is going to use the clock on your iPad, okay? It's going to use the clock. And so if you don't have yours, you can borrow a neighbor's when we get to it, all right? What I want you to do is to pull your clock up. If you're like me, you'll have to find it, all right? And we're going to use the stopwatch, okay? So if you pull your clock up, we're going to use the stopwatch. Okay. And we want to see how close we can get to exactly 5 seconds, okay? And here's what I mean by that. When I get to the stopwatch, I'm going to hit start, and then I'm going to stop it when I think it's about to hit 5. I want to see how close I could get. I'm going to write down the number that's there, okay? So I'm going to go, trying to get to 5 seconds. It's like trying to stop the gas tank. Okay, so 5.04, that would be the first one I would write down, okay? Then I'd reset it, do it again. Okay, so you're going to do it 3 times, see how you can get closer to 5 each time. Oh, 4.84, a little too quick, right? Reset, do it again. So we're going to do it 3 times. Oh, okay, I'm not good at this. Oh, you did good. All right, do it 3 times. Did you hit it? Yes. Woo! Atta girl. After we did this one last year, I would walk around during lessons and kids were back there messing with it, like trying to get it, like they were determined they were going to get it perfect. And so it had been about 2 weeks. I was teaching, we were doing what we're doing, and all of a sudden, kid in the back, yes! And I'm like, what? He's like, he throws his iPad around. It was right in 5 seconds. He goes, I was going to do it till I got it. Okay. What'd you do that time? 4.99. Okay, so do it 3 times and write down your results. And we're going to talk about what we think it might look like. All right, how do we do, anybody? So Brianna hit it. Anybody else? Cam's up here at 4.99 and 5.01, dancing around each side. Okay. So what do you think might happen over time? If I continued to practice and practice and practice, what do you think I would do? I'd eventually get it, right? I get closer and closer. And so what's happening when we do this, all right? If this is 5, eventually we're going to hit that 5, okay? But if we take everybody's data, some of the data is going to be a little bit less than 5. So this might be where our 4.97, 4.98, 4.99, right? Did you get it? And then on the other side, we might have 5.01 or 5.02 and so on, okay? So it's going to make this shape eventually, okay, where it looks like this. What have we been calling that? when it looks like that? Symmetric, okay? It would actually be a really symmetric distribution. If we continue to do it over and over and over, we took a lot of data from a lot of people, it would look like that, okay? What's cool about this distribution, it's referred to as a normal density curve. And the neat thing about a normal density curve, all right, is that in this one, the mean is approximately equal to the median. Okay, the mean is going to equal the median, which is really nice. Okay. Now what's cool, if we look back at the first one we drew, which was that rectangle shape, everybody would work out to be the same. Okay, our uniform density curve, and then we have that normal where it's symmetric. What's cool about both of those is the mean and the median are always pretty much equal to each other in both. Okay, totally different shapes, but the mean is going to equal the median again. Okay, so mean is approximately equal to the median. Right? Now, where it gets weird is when we start skewing our data, all right, in terms of the mean and the median. And so we're going to ignore this task, but I want to draw some curves in here for you. So let's draw this one in. Bless you. That is skewed left. Okay. So let's say we have this data that was skewed left, and then we're going to do one that's skewed right. Okay, which means it's low on the right side. Now, if we're thinking about numbers, let's say we're going 0 to 20 on both of those. Okay, so looking at those numbers on the bottom, right? When we have one that is skewed to the left, okay, that's skewed to the left, the mean is going to come first. Right, so that's going to be my mean. Oh, look, I lied, my median. I always say that backwards. And then my mean, okay? So if I'm skewed to the left, median comes first, all right? Median and then mean. If it's skewed to the right, we reverse that, okay? We reverse that. Did I say that right? Okay, erase all that mess. I'm struggling today. We're going to start over because I need a minute. Okay. Let me draw my pictures. Let's skew to the left. All right. And then let's skew to the right. Okay. All right, when I'm skewed to the right, median is first, okay? So you're gonna hit your median, then you're gonna hit your mean. If we reverse it, all right, we're gonna hit the mean first, if I'm skewed to the left, and then my median. Okay, so what that's saying is when we're skewed left, that the median is greater than the mean. If we're going from 0 to 20, the median would be a higher number. Okay, on the other one, the mean is greater than the median because the mean would be a higher number if we were going from 0 to 20. Right? And those are just one of those things that we're going to put on that reference sheet. Okay, it's not something that we remember real easily, obviously, because I messed it up twice. Okay, when we're doing the skewed ones. But the nice thing is, mainly, we're going to fool with a uniform density curve and a normal density curve, where the mean's going to equal the median. They're going to be in the same place. All right, so that's why I give you those other ones as a reference. Now, what do we do with all this? Okay, why do we need these density curves? Well, what's cool about it is it allows us to find different areas. It allows us to find percentiles. It allows us to find a specific value. When I don't really know all the data, I can find part of the data, which is kind of nice. All right. So I want to talk to you about how we're going to set up these and work through them. All right, and what the questions might look like they're going to ask us to do with these. All right. So we're going to do a little bit of math today. All right. A little bit more than just a normal percentage, but we won't do a lot. Some subtraction, some multiplication, that's about it. Okay. All right, so be sure you got all four of those. The uniform density curve, which is your rectangle, your skewed ones, okay, and then your symmetric one, right? All right, flip that over and let's kind of organize it in one place. If you would, just leave those dice up on the top of your box and I'll come back and grab them here in a second. Appreciate you. Don't you put my dice in your pocket. I saw you. Josue. Don't be making money with my dice. I know. All right. So here we go. So let's put some quick things together back here, some notes. All right. So our different density curves, okay? Let's do that uniform curve. Right? I'm going to give it to you in some just generic symbols, all right? I'm going to go out to a distance of k, right? And I get this rectangular curve. The height is going to be 1 over k, all right? So whatever that number is out there, all right, my height's going to be 1 over that number. So we're just going to keep it really simple. And the area inside will always equal 1. It represents 100% of the data. Okay, so that's your uniform density curve. Makes this rectangle. Okay, everything's the same. Okay. When we get to a normal density curve, okay, a normal density curve, it is symmetric, all right? So it's going to be a symmetric curve. It's going to look like that, kind of looks like a mountain, right? Now, drawing a normal density curve is interesting, right? Because in the middle is where we're going to put our mean. We know the mean and the median are the same, okay? Now, there's a symbol that they use for that, okay? It's a Greek letter called mu, M-U, all right? And it looks like kind of a fancy U, all right? A U with two tails. Right, we call that mu. What'd the cow say? Mu. Right, it's a Greek letter called mu. The other thing they're going to ask me to do with that normal density curve is to tell me what other numbers need to be on the number line. And there are going to be 3 numbers that we put there. Okay, 3 on each side. 3 that go forward from the mean, 3 that go backwards from the mean. All right. Each one of those is 1 standard deviation, all right? So if my standard deviation is 4, I add 4, add 4, add 4 to go forward. To go backwards, subtract 4, subtract 4, subtract 4, all right? So we're going to go forward, standard deviation. We're going to go backwards, standard deviations. The symbol they use for a standard deviation is that sideways 9. It is sigma. And of all the things we're going to do today, setting up a normal curve is the easiest. You're literally adding and subtracting. Okay? We add that standard deviation 3 times, we subtract it 3 times. Okay? And then the last thing is about where those means and medians are located. All right? We know that on those first 2, means and medians are equal. All right, so means equal to mean. Mean is equal to median. It'll be in the middle of both of those. Mean equals median. Right? But if we look at, again, I'm just going to sketch them up. You've got them on the front, but I'm just going to put them in one spot. All right, you got your left and your right. Okay. Median and then mean. The other way, mean and then median. Okay. So let me show you about some of the things they're going to ask me to do. All right. They're going to ask me to draw, all right, all of our different density curves. They're going to ask me to find some values. They're going to ask me to do things like interquartile range. How do we do that when we don't know any of the specific data points? Okay. So I'm going to show you how that works. All right, so let's take a look. So let's see. How does your web browser get a file from the internet? I really don't care. It just does it. Your computer sends a request for the file to a web server. The web server sends back a response. For one particular web server, the time in seconds after the start of an hour at which randomly selected request is received can be modeled by a uniform distribution on the interval from 0 to 3,600 seconds, okay? What that's done is it's told me how long the bottom of my rectangle is going to be, okay? So if it's uniform, we know that it's going to be a rectangle. So that's what I'm going to do. I'm going to start out by drawing that, right? So I'm going to go from 0 to 3,600 seconds, all right? That's what it means by an interval, all right? That's what's going to be my number line on the bottom. So if I start at 0 and I go to 3,600, how long is it? Not a trick question. It's 3,600, okay? This is talking about time. And so what would my height be on the left-hand side? Yes, 1 over 3,600. That's all we have to do, okay? That's all it wanted me to do on that problem, was draw the rectangle, okay? So if it says, give me a uniform distribution, okay, it'll tell me what the bottom is. Now, there's one on your assignment today that says that it talks about the time you have to get up, so you set an alarm for 5 minutes before and 5 minutes after, okay? So think about that. If I set an alarm for 5 minutes before and 5 minutes after. So 0 is the time I want to get up. 5 is the 5 minutes after. What would the number be for the 5 minutes before? If it's a number line. It'd be a -5, okay? So this would be 5 minutes after, 5 minutes before. So you get a negative, okay? Now, here's the tricky part. How long is it from -5 to +5? Not 5, it's 10, right? Because I went from -5 to 0, that'd be 5. 0 to +5, 5 more. So the bottom is actually 10. What does that mean the side's going to be? It's over that total length. So if the total length is 10, it would be 1/10. Okay? So that can be a little bit tricky. So if they ever give you one that doesn't start at 0, okay, see how long the whole bottom is, and that's what your reciprocal is going to be on the side. Okay? So that's a little bit tricky, so I wanted to point that out. Okay? Are we good with the first one, though? 0 to a number, 1 over that number is the side. Okay? Now, this is what's is interesting. It says about what proportion of requests are received within the first 5 minutes, or in other words, 300 seconds after the hour. Okay? What it's asking me for right there, we know my whole rectangle goes out to 3,600. Okay? But I don't need the whole rectangle. I only want to go to 300. And I just want to find the area of that blue spot. Okay? Does anybody remember how we find areas of rectangles? Length times width. We just multiply. So the length that I want on the bottom is 300 times my height, which is 1 over 3,600. Okay? And that's going to be my answer. We're just going to multiply. Whatever that length is, it gives me to find on the bottom times that height on the side. Okay? It's just going to be a decimal. So you can pick up your calculator and type that in. 300 times 1 over 3,600. And I think you should get 0.083. Okay. So sometimes it's going to say, hey, I don't need the area of the whole thing. I just need the area of a little piece. Right? How much is in that little piece? Now, look at this next one. I think this one's interesting. It says to find the interquartile range. Whew. All right. Anybody remember how we find IQR? How do we talk about doing it last chapter? I know. Heaven forbid things come back. Yeah, Q3 minus Q1. Okay? But what makes that hard is I got no idea what data is in that rectangle. Okay? So we have to think about what the quartiles represent. Q3 is 75% of the data. Q1 was 25% of the data. Right? So what we're going to do, for Q3, 75% would be 0.75. The whole length was 3,600. Okay? So I don't want the whole height, I only want 75% of it. Okay? Q1, I only want 25%, so 0.25 times 3,600. We're going to get those two numbers, and then we're going to subtract them. Okay? So to get your interquartile range takes a little work. Right? Takes a little work. So I believe for quartile 3, you get 2,700. And then for quartile 1, 900. And so for our interquartile range, we would subtract them, which would give me 1,800. So just a little extra something, something. Again, not hard, just extra, all right? So if you're asking for quartiles in a uniform, we just don't know enough, okay? So we have to make it those decimal approximations, 75% for quartile 3, 25% or 0.25 for quartile 1. All right, again, I don't know the specific data, but it wants me to find the mean, okay? In a uniform curve, the mean's in the middle, right? The mean would be in the middle. So if the whole thing's 3,600, how would I get the middle? If I go from 0 to 3,600, where would the middle fall? It'd be half of it, right? We just divide it by 2. And we get 1,800. Okay? So if you're uniform and you're looking for a mean, it's just half the data. All right? Divide it by 2. Okay? It's uniform. If the mean is 1,800, what does that mean the median is? 1,800. Okay? Because they're equal. All right? Because mean is equal to median. Now, typically I won't do all the extra examples, but today we need to, all right? Just because you're going to see these in your homework and I want you to actually know how to do it. In fact, we've not even done anything with that normal curve yet, so we need to for sure set one of those up, okay? So I want to walk you through a couple of these and see if we can figure it out, okay? See if we can figure out what we need to do. So look at your extra examples, okay? So it gives me a lot of information here, but basically it says you use a calculator to generate some numbers between 0 and 4. Okay, whenever you see between, that's what's going to be on your number line. Okay, so between 0 and 4. And it's going to generate a long sequence of random numbers. All right, so it says to draw a density curve to model this distribution. Well, it's going to be uniform. We're going to go from 0 to 4. That means it's just a rectangle. And, and what's the height going to be? 1 over 4. Okay, that's all it wanted me to do. Okay. So that bottom is the only thing we generate, and that's my random number. Okay. Now, this is where it gets interesting, all right? Because this time it says about what percent of the generated numbers fall between 0.87 and 2.55, okay? So what it's saying is in this box from 0 to 4 that goes up to 1/4, how much is between 0.87 and 2.55? So this is the rectangle it wants me to find, okay? So it's not the whole rectangle. It's not one end of a rectangle. It's this middle piece, okay? It's that middle piece. How are we going to get that, all right? What do we do? Well, we're always going to multiply by that 1/4 because that's my height, all right? So I know I'm going to multiply by that 1/4. But how do I get this distance on the bottom that's between those two numbers? Any ideas? How might I figure out how long that little piece of the rectangle is? Close. Subtract. We want the difference, okay? So we take 2.55 minus 0.87. Okay, so 2.55 minus 0.87, and we'd multiply it by the 1/4. So you always multiply by whatever's over here on this height. Okay. If you do that, I believe you'll get 0.42. This would be what we would call a proportion, all right? But it didn't ask me for a proportion. It asked me for a percent. And the only way to get the percent is to take that decimal and multiply it by 100. Okay, so if it says proportion, you'll just leave it as a decimal. If it says percent, you'll multiply it by 100. Okay. All right, next one, hardest one we have to do. All right, hardest one we have to do. Okay. This time it tells me to find the 65th percentile. So this is weird, okay? It's giving me that percent. So that process we just did, it kind of wants me to go backwards, okay? It wants me to find that 65th percentile. So let's make it a decimal. To make it a decimal, we're going to divide by 100, okay? So what decimal would it give me? 0.65, okay? So we're going to actually kind of solve a little bit of an equation here, which is weird, okay? We know to get that proportion, we took our height, right? And then we took some number and subtracted it from the start, okay? Where did that distribution start? Did it start at 0? 0 to 4. So we're going to take this number that I'm looking for minus 0. Okay, so all I did was go backwards from what we just did a few minutes ago, right? All I did was go backwards. Now, if I have a number and I take 0 away, what's left? If I have 4 and I take nothing away, what do I still have? 4. Yeah, so I'm just going to be left with an n. So I have 1/4 of this number is 0.65. And as long as you start at 0, it's just going to be your height times the number. The only time it changes is if we don't start at 0. Like when we were talking about the alarm clock when I started at -5. Okay, so that would look different. Now, to get my n by itself, I can take 0.65 and divide it by 1/4, or easier, I can just multiply by 4. Right? So the number I'm looking for is 0.65 times 4. So that's the number that we're looking for. And I believe it's 2.60. Right? I think there's one in your assignment today where you have to do that. Quickest thing or quickest way to remember, all right, it's what I tell people to do, is we're going to take the number, we're going to convert our percentage to, so let's say I was looking for the 25th percentile. Okay? That's 0.25. The number I'm looking for is going to be, okay, if I start at 0 and say I go to 7, right? We're just going to always multiply by that number on the bottom, okay? So you can kind of skip the whole equation process and just multiply by that number that's on the side as long as we start at 0. If I don't start at 0, then we got to do it the equation way, okay? But I don't think I ever ask you for one that doesn't start at 0, okay? All right, so let's look at just 2 more quick things. Right? Most of your work will be about the uniform density curve, all right? So most of it will come from there. So at the top, it's giving you some pictures, all right? On the bottom one, it's giving me a curve, and it's asking me which one could be the mean and which one could be the median, all right? So here's what we have to know. Is this one symmetric? Down here at the bottom, is this symmetric? No. Which way is it skewed? Or is it shorter? Left. Okay, it's skewed left. And when we have one that is skewed to the left, all right, the who comes first? The mean and then the median, all right? And so when we think about where our median is always right before you get to the highest number. So that's going to be my median, right? And then A would be my mean, because that mean would have to come first. So there's going to be one where it's going to give you a picture, and it's just going to ask you which one's the mean, which one's the median. So just look at your pictures from your notes. Okay, match those up. All right, last one is drawing a normal curve. So I want to walk you through that. Okay, and then we're going to practice. We'll be done. Okay, again, the bad part about this is that it's got a lot of words. Okay, so let's look at what's important. All right, it's talking to me about baseball players and their batting averages. I look through all the words, and then I see some that I know. Normal, let's do this, normal distribution. Okay, so that means I'm going to make that U-shaped curve. Okay, that bell-shaped curve. It tells me the mean is 0.261. I'm going to need that. It's going to go in the middle. Then it tells me the standard deviation is 0.034. So we're going to do some addition and subtraction. Okay. We want to draw the normal curve and label those 3 marks before and 3 marks after. So this is what I tell people to do. Number line, mean in the middle. So 0.261. Okay. It's going to be the tallest point on my graph, so I'm going to draw it there in the middle. Right? So this is my mean. That's where you get that mu. 1, 2, 3 to the right. 1, 2, 3 to the left. Okay. What we're going to do is we're going to add the standard deviation to that 0.261, and then we're going to add the standard deviation to the answer we get, and we're going to add the standard deviation to the answer we get. Okay? So this first number on the bottom of my number line, my standard deviation is that 0.034. So I'm going to pick up my calculator, and I'm going to type in 0.261 plus 0.034. Okay? So plus 0.034. And so the first number that I'm going to do going forward is 0.295. Right? Then I'm going to add that 0.034 again. So 0.034 to that number. And that gives me 0.329. Do it one more time. Plus 0.034. And I get 3.363. Okay, so as I go forward, right, I add that standard deviation number each time. Okay, to go backwards to the left, we subtract. Right, we subtract. So I'm going to do minus 0.034 each time. So start in the middle, 0.261. Minus 0.034. So 0.227. Do it again. Minus 0.034. 0.193. Do it one more time. Oops, wrong color. Okay, it's going to ask you just to pull the numbers onto that number line. That's all it's going to ask you to do. Okay, now it will draw that uniform curve so that it hits the top and looks like that for you. It'll look something like that. Okay, all you'll have to do is put in the blue numbers. So it's going to draw that curve in. Question about the normal curve. That's the only thing we have to do with it today. We're going to spend the rest of the unit talking about that curve. So today it's just drawing the picture. Okay, and we do have an applet that'll draw it for us. So we'll learn about that in a day or two. Okay, next week. So add to go forward, subtract to go back. Okay, add to the right, subtract to the left. Okay, all right, your assignment is up. Okay, it opened at 2:30, so you can go ahead and get in there. There's only 4 questions today. Okay, so let's go ahead and maybe the internet will play nice. If not, I'm going to call the technology help desk because I don't think my access point's working right. Okay, and then we'll go tinkle here in just a second.